Welcome to the NETFABB simulation tutorial on generating a process parameters file. As explained more fully in the first tutorial, the process parameter file, or PRM file, records the physical properties of a specific build material, such as its density and thermal conductivity, along with the process parameters of the build machine, such as laser power and scan speed. So whenever we use this same combination of material and process parameters, the PRM file can be reused to provide the input data for simulating thermal and mechanical response of a manufactured part. An overview of the process of PRM file generation is as follows. Enter the machine process parameters into NETFABB simulation, select a build material from the database, and then generate the PRM file. In NETFABB simulation, we start on the Home tab by clicking Processing Parameters. Note that the library contains some PRM files for common combinations of materials and processing parameters, such as this one for Inconel 625. But we're going to create a new PRM file, so we start by clicking New. In the new Process Parameters dialog on the Physical tab, you can see the machine process parameters at the top and the material selection below. So we're going to change the settings here as follows. We want a laser power of 150 watts, heat source absorption efficiency of 40%, laser beam diameter of 150 microns or 0.15 millimeters, travel speed of 600 millimeters per second, a layer thickness of 40 microns, 0.04 millimeters, a hatch spacing of 140 microns or 0.14 millimeters, and a recoder time of 10 seconds. This, by the way, is the time required for the recoder blade to rake over a new powder layer and return to its starting position. And then we'll leave interlayer rotation angle at 67 degrees. For the material, we select from the database Inconel 718. Note that this dialog also has two other tabs. An Analysis tab where you can select to report on stress and distortion, or hotspots and lack of fusion, or both. And an Advanced tab which provides encryption options to protect the intellectual property in your PRM file and to improve simulation convergence by using thermal and/or mechanical relaxation settings. For this exercise, we will leave the default settings, and we'll choose to generate the PRM file. We are prompted in this dialog to approve the current path to the process parameters library, and this can be changed only on the simulation menu's settings dialog. Also, it's important here to provide a descriptive name for the new PRM file, and you can see that the proposed file name does just that. When the PRM generation starts, the Job Manager opens automatically. Here we can see the job progress, the start time, and the computer name where the job is running. Now, this process of PRM generation uses more computational resources than the simulation of a part built with an existing PRM file. So we're not going to wait while it takes a couple of hours to complete. In the Job Manager, we select the job and click the Cancel button in the upper left. If you do create a new PRM file, you will see it added to the Process Parameters library with the name you gave it. Now, to review what we did in this tutorial, we entered the machine process parameters into NETFABB simulation. We selected build material from the database, and we saw how to generate a PRM file. For your next tutorial, to run a part level analysis is recommended.